Hello everyone. In this video, we're going to talk about the diversification of market risk. So the diversification is really saying that if we invest in multiple assets, right, and they are jointly better than if we were to invest each of them individually. So, as the old saying goes, diversification is the only free lunch in finance. So this is attributed to the Nobel laureate Harry Markowitz. So essentially says that there's a benefit in diversification. So let's try to look at this diversification benefit from a more quantitative perspective. Okay, so we mentioned that we can represent the randomness using a random variable. Okay, so assume this is our random variable, and then we have assume we have two assets. One is stock and one is bond. Right. So we use one random variable called RS to represent the returns for the stock, and then another random variable RB to represent the return for the bond. So both are random variables. And typically, when we describe the random variables, we would like to know some statistics about the random variable. For example, what is the mean and what is the variance? Okay, so what is the variance? The mean represents the average return for stock or the bond, and the variance represents how much deviation, right, from the mean. So this variance essentially captures the deviation from the mean, right? And we're going to represent their mean and the variance, and then also represents capture the mean and variance of the portfolio. Okay, so if we were to go into diversify, right, we're going to have a portfolio, and then this portfolio essentially is a collection of individual weights. Okay, so for example, the example portfolio could be I invest 60% or 0.6 in stock, and then therefore I have 40% in bonds. Okay, so this is the one portfolio. I could say 50-50. This is another portfolio, and etc. Right. So when we talk about portfolio, it essentially refers to how do we allocate our weights to the assets. So assuming our total weight is one, right? So they jointly need to sum to one. And then if we are going to hold the asset only, right? And then each of the weight needs to be in between 0 and 1. So these are some additional constraints. Okay, so if we were to represent it more generally, right, we see that we can invest W in the stock and therefore have 1 minus W in the bond. Okay, so this is our very general representation of the portfolio. Now, if we look at portfolio, then what is the corresponding portfolio statistics in terms of the mean return and also the variance? Okay, so mean we say it is RP, and the variance we just use the sigma p square. Okay, so this is okay, so this is just a way to represent the to rest notations, right? So we're going to use the uh, so we're going to use sigma p square to represent the variance. Now it turns out that we can represent these two quantities based on what we have here. So we have RS and RB to represent the returns for each individual asset. And we have the weight allocations. Okay, so W goes to stock and 1 minus W goes to bond. So let's look at the returns first. So as a portfolio, now what is the return for the portfolio, right? So it really depends on how much we invest in each individual asset. Okay, so we have the returns for stock and returns for the bonds, right? So, and we invest individually W for stock and 1 minus W for bond. and therefore we're just going to do a weighted sum. Okay, so we sum these two returns and then weight them by the respective weights. Okay, so the proportion of assets we invest in each asset. So this is W, and this is 1 minus W, right? And this is essentially a weighted sum. Okay, so this is the weighted sum. So this is our portfolio return, right? But the diversification is not really saying something about the return itself. So if we have this is maybe okay, so let's say this 10%, okay, and that is 2% for the mean. Okay, so let's say for the mean it's 10% and 2%. And we do, for example, 50-50. Now the weighted sum will just give us the average of these two, okay, if they are just 50-50, which is 6% in this case. Okay, so nothing new about the return if we talk about diversification. So return is just a weighted average. There's no diversification. Okay, so the diversification comes in when we talk about risk, which is the sigma p square. Okay, so this is the risk for the portfolio. So it turns out that if we were to look at the portfolio risk, it's going to be lower than if we were to do a weighted sum. Okay, and we're going to show why that's the case. So let me just erase this portion and then try to express the portfolio variance and let's see how it compares to the weighted sum version of the variance. So let's try to express it here. So when it comes to the portfolio variance, it's essentially we look at the return for the portfolio, right? So this is RP, and we're going to extract the variance of this quantity. Okay, and now at this step, we're just going to plug in. So this is the formula for the returns. We're going to see that we're going to extract the variance of this quantity, where itself is a portfolio return, which is essentially a weighted sum between these two quantities. All right. So, and now the next thing would be, what is this variance doing here? So variance, as we mentioned earlier, it is referring to the spread, the average deviation from the mean. Okay? And if we were to move this variance to each and every piece individually inside the bracket, then we have this. Okay, so we're just going to apply the usual variance operation to each and every term. So, so it's going to consist of three terms. The first term will be W squared, and then the variance of this RS. Okay, so this is one piece. And the other one would be 1 minus W squared, and then the variance of the bond's return. Okay, so this is again, this is a weighted version. We just square them. The other piece would be the covariance term. Okay, so that would be 2 times W times 1 minus W, and it's going to be covariance between these two assets. Okay, so this is the covariance. So why does a covariance term here? And that's because they are correlated. Okay, so if they are not correlated, then this term is going to be 0, and then it's going to cancel out. Then essentially the variance is just going to be a weighted sum. Okay, which is not the case because the bonds and stock, although they are not so correlated, but there's still a bit of correlation. Okay, so we cannot really cross it out. So essentially, this term represents the co-movement between these two assets, and this represents individually how much is their variance, and then we're going to do it with this sum. All right. So at this step, let's try to re-express it more compact, in a more compact way. So let's say that This is just going to be W square and then sigma S square. Okay, so this is just a more complex notation. This represents the variance for the stock. Okay, and I have another term which is variance for the bond, right? Variance for the bond, and then the weight is going to be 1 minus W square. All right, so this is variance for the bond. And then we're going to plus the additional terms, is 2 times W, 1 minus W. And also there's a covariance terms. For the covariance, we're going to express it a bit differently. Okay, so this is a correlation rho between stock and bond times the variance, the standard deviation for the stock and standard deviation for the bond. So this is just the definition of covariance. Okay, we're just plugging in the definition of covariance. But note that the key term that's appearing here is the rho factor. So this is rho, which represents the correlation. Okay, this is a correlation factor, and it's usually in between -1 and 1, right? So if it's 1, that means it's perfectly correlated in a positive way. If it's -1 and it's negatively perfectly correlated. So usually we're going to see that we prefer assets which are not so correlated. So as long as they are, so the more they are uncorrelated, the better. Okay, and we can more or less see something about this already. So if we're going to look at just this term, okay, so this term itself, because rho is always going to be less than or equal to 1. Also in financial markets, it's always going to be less than 1 because it's very difficult to find two exactly assets which are perfectly correlated with each other. Okay, so what we see here is that, let me try to erase this portion. So what we see here is that we can use the fact because rho itself is always going to be less than 1 in the financial market. So this quantity is going to be less than W square sigma S square. Going to just write the previous two pieces and also plus, right? So 2 times W minus W and also sigma S and sigma B. Okay, so we're just using the fact that the rho factor, the correlation is less than 1. And then this portion itself is just equal to, we're going to write it in the squared version. So this is W sigma S plus 1 minus W sigma B, and we're going to do a square. Okay, so this is the definition of the squaring effect. So if you still recall, a plus b square is equal to a square plus b square plus 2 times ab. Okay, this is just plugging in the definition. Now let's try to wrap it up and look at the starting point and end point. So what we have is that this guy, the portfolio variance, okay, is less than the weighted sum of the individual variances. Okay, so this is just something I'm going to write it out. And then, okay, so because the standard deviation or the variance is always positive, right? And then that leads to, can take the square root of both sides. So this is less than the weighted sum of the two assets. Okay, so this is the key result we have, and this is what diversification is about. It says the portfolio standard deviation. Okay, so standard deviation is just the square root of variance. Okay, so and now this is portfolio volatility. Can also say this is the portfolio volatility. It is less than the weighted sum of these two assets. Okay, so this is the individual standard deviation or individual volatility, and we do a weighted sum. So recall that for if it's for the mean, right, it's just weighted sum is equal to each other. So just recall that the portfolio variance return is equal to the weighted sum uh, of these two guys. This is 1 minus W. And then in terms of a mean, so we can actually take the mean. So if we just focus on the mean, it's going to be mu P go to W mu S plus 1 minus W mu B. Okay, so mu just represents the mean, the average return. Okay, but this is just to say that if it's for the average return, nothing new. Okay, it's just a weighted sum. But if when it comes to the variance or the volatility itself, the joint or the portfolio volatility is less than a simple weighted sum of individual volatilities. Okay, so this is the diversification effect. So if we're going to diversify, invest in multiple assets, because in the market, it's very difficult to find assets which are perfectly correlated, which means that the correlation is less than one, and then that leads to this result, which is the diversification result. So if we diversify, if we invest in multiple assets, no matter what our weight allocations are, okay, so no matter what the W, the value is, we're always going to get a portfolio with a lower risk than if we were to invest individually. Okay, so that's the key results for diversification. Okay, so now let's look at a bit of results. So this is an example where we invest in the two assets. So this is the S&P 500 index. This is another bond index. So this is the curve of the bond, and this is the stock. Okay, so we see that the stock is more volatile than the bond. However, if we're going to invest and diversify across these two assets using the 50-50 strategy, so which means we hold half of each asset, and then we're going to get this blue curve in terms of how much money we're going to have at each and every time period. So this is a wealth curve. Okay, so this is how our wealth grows. So clearly, you see that this is better than just the bond. So we are above the bond. But also, if you look at these two, so although we're not as high return as the stock, but we are less volatile than the stock. So this means that diversification itself lower the risk, lower the volatility. Okay? So of course, you cannot expect to get the same volatility, the same return, but less volatility. So that's very difficult. So if you want to have more stability or less volatility, then this essentially in a way we're sacrificing the return. Okay, we have low return, but we have much better volatility or much lower volatility. Okay, so that's the illustration of and the equal weighted portfolio, which is a blue line, versus the buy and hold in a single asset. And this is just an example of the bull market. So the benefits of this diversification is more obvious in the bear market case. All right. So that's it for this video, and thanks for watching.